Hi, welcome to our channel of IGNOU Audiobooks, School of Agriculture, SOA Certificate in Organic Farming, COF. BAPI01 Organic Production System. Block-1 Farm Management. Unit-4 Contamination Control. 4.0 Objectives. After going through this unit, you will be in a position to define contamination and implement its control procedure. Assess the nature and source of soil and water contamination. Describe the National Guidelines, NPOP, on contamination control. Explain the ways of protecting farm ponds and wells, and analyze the contamination control for pesticide spill. 4.1 Introduction. As we have studied, organic farming not only excludes the use of any form of chemicals but also emphasizes the protection of farm and operations against any form of contamination either from outside of farm or within the farm. If any prohibited material reaches to the organic farm, the contamination takes place. The products generated under such conditions is not certified as organic. Contaminants are the prohibited substances or organisms. The contamination Contamination refers to efforts to prevent or minimize the possibility of unintended contact with those substances or organisms which are contaminants. The contaminants depend on the agricultural activities and are generated from either well-defined source or from sources that are not so well-defined. The sources could be either point or non-point sources. A point source of pollution is effluent discharged from one location such as a pipe, tank, pit or ditch. Non-point source of pollution originates from not a well-defined source, such as runoff from a field or from streets in a city, making identification and assessment of sources difficult. Contaminants related to cropping practices include nutrients, nitrogen and phosphorus, herbicides, insecticides, sediments, salts and trace elements. The contaminants are carried over to surface and groundwater through all phases of the hydrologic cycle. Contamination control approaches help containing the spread of the contaminants in the environment, soil, water courses, reservoirs and wells. The tillage, irrigation, and drainage practices, the volume, timing, and placement of fertilizer, herbicide, and insecticide, the sequence of crop rotation, soil characteristics and weather conditions may also influence the contamination and its control. The control measures aim producing organic farm items that can meet the standards of certifying agencies besides achieving sustainability and safety of agricultural production system. Contamination risks in organic farming. Now, we shall see the potent contaminants, which if not prevented may risk in organic farming. In many situations, there is a risk of contamination from activities happening on the adjacent farm, like in the case of aerial spray of pesticide on horticultural crops through spray drift, treatment applied by the government agencies for treatment of malaria, control of obnoxious weeds and pests also causes contamination. We may visualize the risk through import of compost, implement and other inputs or materials from non-organic fields. Genetically modified organisms, GMO, like seeds or any other input are the other source of contamination. We should develop a comprehensive contamination risk management strategy for our organic farming system. One such example has been illustrated in the appendix given at the end of this unit. Below we shall study the contamination and their impact on different systems. Also describe the methodologies to decontaminate them. 4.2 Soil contamination. The soil contamination refers to the presence of inorganic ingredients in the soil. Soil contamination arises mainly from the application of fertilizers and pesticides. In addition, direct discharge of industrial wastes to the soil, and percolation of contaminated surface water to subsurface contaminates the soil. The most common chemicals involved are petroleum hydrocarbons, solvents, pesticides, lead and other heavy metals. Percolation of pesticides and herbicides into the soil when used for agriculture is the common mode of soil contamination. It includes a variety of chemicals, including DDT, lindane, organochlorines, organophosphates, carbonates, and cycladines. Besides this direct contamination of the soil, runoff water may also carry contaminants to the organic fields. The contaminants like lead, mercury, chromium, cadmium, bacteria, hydrocarbons from solid waste disposal sites may also leach into the organic farm. Dusts containing zinc, cadmium, lead and mercury emanating from coal-burning power plants and smelting operations may also drift onto the soil in an organic farm. 4.2.1 Nature of soil contamination. Contaminants become entrained in soil by a variety of mechanisms. One has to understand these mechanisms to comprehend the fundamental nature of soil contamination. Soil particulates are composed of organic and inorganic chemicals. They vary in their cation exchange capacity, buffering capacity, and redox potential. At one extreme, the sand component is a coarse-grained, totally inorganic substance, which is inert. On the other extreme, peat soils are fine organic materials which are highly active. In general, many soil subtypes comprise a soil, which have complex characteristics. The soils are diverse in soil porosity, ranging from gravels to sands to silt to clay, and pore size. This leads to variations in chemical bonding or adhesion characteristics. Hence, each contaminant has a different bonding mechanism with a given soil type. Some contaminants may drain through soils, move to other soils or deeper aquifers. Organic chemicals discharged into a clay soil will have a very high adsorption. In most occasions, the contaminants adhere to the surface of soil particles or stain the interstices of a soil matrix, resulting in soil contamination. There exists a dynamic equilibrium, where new contaminants may adhere to new soil particles. Further, movement of groundwater may transport some of the soil contaminants to other locations or depths. Spilling or burying of hazardous substances contaminates the soil. Migration of the spill occurred elsewhere also contaminate the soil. Smelting operations, smokestacks or other similar activities release small particles containing hazardous substances into the air that fall and adhere on the surface of soil. Particles, hazardous substances that are deposited on the soil are washed away when rain comes or during irrigation and contaminates the soil at the destination or on the way. 4.2.2 Impact of soil contaminants on ecosystems. Soil contaminants can have significant impact on ecosystems. Presence of many hazardous chemicals even at low concentration may create drastic changes on the soil chemistry. These changes may influence the metabolism of microorganisms and arthropods living in the soil. Such a contamination may eliminate some components, especially in the primary food chain. This may deprive the predator or consumer species. The impact of such contaminants may be limited on lower life forms, but it may be carried to the higher levels of the food chain by an enhanced concentration in each stage of the food web. This bioaccumulation or biomagnification has led to extinction of many species. For instance, biomagnification of the persistent DDT material in the food sources of many birds has led to the extinction of those species. On the other hand, soil contamination in agricultural lands change plant metabolism, thereby reducing crop yields. This may eliminate the crop cover of the soil, making the soil more prone to soil erosion. Half-life period of some of the contaminants is usually longer. In some cases, primary soil contaminants decay in due course, resulting in chemical derivatives. These also significantly influence crop yields. 4.3 Water contamination. Water contamination may occur in both the surface and groundwater. The contamination of surface water could be easily controlled compared to that of groundwater. It is complex because the groundwater moves over long distances through aquifers. In clay soils with non-porous aquifers, the contaminants like bacteria may be easily removed by simple filtration, adsorption and absorption, or by chemical reactions and biological activity of water. In other cases, where filtration or other soil processes are not effective, the contaminants are simply transported. Ineffective filtration also enables the contaminants in the groundwater to move through cracks and reach the surface water. 4.3.1 Nature of water contamination. The process of water contamination is complex. The water contamination increases the nutrients that may lead to eutrophication. Oxygen demand increases in water when organic wastes are dumped. Such a situation depletes oxygen that ultimately affects the ecosystem. Industrial effluents carry heavy metals, organic toxins, oils, and solids that constrains oxygen availability. Runoff water with silt and other contaminants blanket the lake or river bed, inhibiting the penetration of sunlight through the water column. This damages the ecological system. 4.3.2 Sources of water contamination. Water may be contaminated by various sources. Pesticides or fertilizers carried by the surface runoff constitute the primary source of contamination of water for organic farming. Slash and burn farming practice, usually associated with jhum cultivation, is also a source of water contamination. Discharge of industrial effluents, untreated sewage, spilled petroleum products, and seepage from underground storage tanks are the other sources of contamination affecting water. Sulfur dioxide emanating from burning of fossil fuels lead to acid rains also contaminate water. Surface runoff water carrying silt from construction sites, farms, and other impervious surfaces may also cause water contamination. 4.3.3 Organic and inorganic contaminants. The organic contaminants may be insecticides, herbicides, and other chemicals, bacteria from sewage or livestock operations, pathogens from food processing. Wastes may also contaminate water. Debris from logging operations in forests contaminates water sources. Industrial solvents escaping from improper storage structures also contaminate water. Inorganic contaminants of water include heavy metals, industrial discharges, especially sulfur dioxide from power plants, nitrates and phosphates in the fertilizer. 4.3.4 Mode of water contamination. Water contamination may occur either directly or indirectly. The direct contamination of water is mainly because of spraying operations, spillage of pesticide concentrate when mixing and loading in the sprayers, leakage of stored concentrate, or discarding unwashed empty containers in or near a water supply, back siphoning or overfilling of sprayer tanks, rinsing or washing spray equipment, and spray drift under windy conditions or application too close to open water are the common modes of direct contamination of water. In porous soil, pesticides can readily leak in and contaminate the well water. In clay soils, rainwater percolates down into the well carrying the pesticides. Indirect contamination of water occurs due to movement of pesticide from treated land. Heavy rains and runoff water facilitate the movement of pesticide. Ultimately, it seeps into the Groundwater through aquifers. Soil particles and pesticides from treated fields or spills are carried by surface runoff into streams, ditches, ponds and wells. This normally occurs when heavy rain follow within a few days of a spray operation, although it can also happen any time of the year with pesticides that persist in soil. The greatest loss occurs when rains fall within 24 hours of application of pesticide. Removal of pesticides from the soil surface decreases with time following the application and is usually negligible 1 week after spraying. Runoff is normally more severe on clay soils than on sandy soils. There are pesticides that are persistent and water-soluble. These will move through the soil and reach the water table ultimately. 4.4 Air contamination. Controlled burn practices used in agriculture and forestry management. Dust particles emanating from industries, fly ash from thermal stations, automobile exhausts are the main sources to contaminate the air. Impacts of air contamination in organic farming, especially in developing countries like India, is minimal. 4.5 Groundwater contamination. Groundwater is most crucial source of water for drinking and agriculture. Irrigation. TTS safety decide the safety of plant and animal, including human on the earth. Groundwater is a body of water that is contained in underground waterways known as aquifers. Because groundwater flows through compressed gravel and soil deposits, it flows very slowly. We know the groundwater is replenished through two sources, those are percolating rain or snow meltwater and recharge zones where the aquifer contacts the surface. During its replenishment, the groundwater is vulnerable to contaminants that may be in the surface water or the soil. The aquifer may be protected from surface contamination by the presence of underground deposits of impervious materials such as clay or bedrock. For example, a sanitary landfill constructed in sand and gravel deposits is more likely to lead to groundwater contamination than a landfill constructed in clay deposits. Microorganisms, inorganic chemicals and organic chemicals from many sources may contaminate groundwater. Joseph Salvato, in Environmental Sanitation and Engineering, lists sources of groundwater contaminants that fall into the following 4 categories. Waste category. These are systems designed to discharge wastewater onto the surface of the land or to the groundwater. This category includes land application of wastewater, septic systems, waste disposal wells and brine injection wells. Waste category 2. These are systems that may discharge wastewater to the land or groundwater but are not designed to do so. This category includes surface impoundments such as lagoons, landfills, and other excavations, animal feedlots, leaky sanitary sewer lines and acid mine drainage. Non-waste category 3. These are non-waste systems that may discharge contamination to the soil or the groundwater. This category includes buried storage tanks or pipelines, stockpiles of such things as agricultural activities and accidental spills. Non-waste category 4. These are non-waste and non-discharge sources of contamination. This category includes saltwater intrusion, river infiltration, improperly constructed or abandoned wells and farming practices. Groundwater contamination presents very complex issues. Once an aquifer is contaminated, merely removing the source of contamination will not clean it up. Control of groundwater contamination is dependent on 4 interrelated systems: regulation, design, monitoring, and remediation. Regulations intended to control groundwater contamination are very difficult to enforce. Numerous federal acts in European and American countries have been enacted. Some of them are Resource Conservation and Recovery Act, the Superfund Act and the Safe Drinking Water Act are designed to protect groundwater. Building control and monitoring measures into new facilities is the most promising method for long-term regulation of groundwater contamination. Finally, remediation or cleanup of a contaminated aquifer through air stripping, a process by which water is removed from an aquifer, treated to remove contaminants, then returned to the aquifer, should be performed in limited situations. 4.6 Contamination control. As stated above, the contamination control refers to containing the spread of the pesticide to prevent further contamination of the environment, in particular watercourses, reservoirs, and wells. 4.6.1 National Guidelines. The National Organic Certification Program stipulates that all relevant measures should be taken to minimize contamination from outside and within the organic farm. It states that the certification program should set limits for the maximum application levels of heavy metals and other contaminants if there is a risk or reasonable suspicion of contamination. However, the accumulation of heavy metals and other pollutants should be within the prescribed standards. If there is a reasonable suspicion of contamination, the certification program shall carry out an analysis of the relevant products and possible sources of soil and water contamination to determine the level of contamination. In organic farming system, only products based on polyethylene and polypropylene or other polycarbonates are allowed for protected structure coverings, plastic mulches, insect netting and silage wrapping. These products shall be removed from the soil after use and should not be burnt on the farmland. The use of dichloride-based products is prohibited. 4.6.2 Protecting the farm ponds and wells. Farm ponds and wells can be protected against surface runoff water that carry contaminants by creating berm. Berm denotes the area of level ground between the raised earthwork and the ditch surrounding it. The location and protection of well and farm pond are also important. If the well or pond is to be located in treated field where surface water can run off, the contamination can be reduced by excavating ditches or by providing a grassed buffer strip between the pond or well and the treated area. General recommendations on controlling soil erosion is also useful to contain the passage of pesticides to ditches and streams. 4.6.3 Decontaminating farm wells. Well waters are quite cold and often alkaline. Most pesticides are less soluble under these conditions than in waters of higher temperature and at a neutral pH. Emptying the water of well frequently may be adequate to decontaminate the water if low amounts of contaminants have entered as spray drift. Often the bottom of the well should be scraped and the sediment is removed. Often the toxicant is spilled down the sides of the well and hence removal must include washing or scrapping. In the case of stone or cement walls, washing the walls is adequate. If the walls are earthen, the walls should be scrapped to effect a cleanup. This would be followed by emptying the well frequently and releasing the water for at least 30 meters from the well. If there is a pesticide spill around the lip of the well, the contaminated surface soil should also be removed. Decontamination may take from 6 months to 3 years, or in some cases the well has to be abandoned. Cleanup should be rapid when the well is decontaminated by scraping and removing water. Sometime, a large quantity of contaminant is spilled close to the well, especially on sandy or gravelly soils. Then, the pesticide may soak deep into the soil and seep into the well in succeeding years, especially under heavy rainfall conditions. If such conditions happens, the well has to be abandoned. There are no adequate means of preventing contamination from subterranean seepage. With subterranean contamination, wells cannot be decontaminated. Abandonment of the well is the only option available. 4.6.4 Contamination control for pesticide spill. If there is a leak from pesticide container, it has to be stopped. A barrier made of soil, sawdust, newspaper, activated charcoal and vermiculite should be constructed to soak up the pesticide. The spill-up area should be cleaned. Surplus liquid product should be pumped into drums. Damp soil or sawdust should be used to make the dry powder or granular product lightly wet, and then this material should be put into a drum. If the spill occurs on the ground, it is necessary to dig up the contaminated area and place the soil in drums. Leaky or damaged containers should be placed in a drum or heavy plastic bag. If contamination happens inside a building, the area has to be ventilated to prevent the buildup of toxic fumes. If possible, the spill area should be decontaminated. After removing the spilt pesticide, the contaminated area should be soaked with a mixture of equal parts of bleach and water. A dike should be placed around the spill area to prevent the spread of the decontamination solution. All equipment used in the cleanup and the vehicles contaminated by the spill should be decontaminated by following the same procedures. 4.6.5 Human relations. The most effective contamination control is cordial relationship with neighbors. Organic producers may enlighten their neighbors about the organic production, certification and problems of contamination. Then, the neighbors will take care and help avoid possible contaminants across the boundaries from their fields. 4.7 Summary. In this unit, we have seen that the contamination control is an important aspect in organic farming. The potent contaminants include nutrients, nitrogen and phosphorus, herbicides, and insecticides. The volume, timing, and placement of nutrients, herbicide, and insecticide require attention. The contamination of soil, water and air pose problems to the organic farming practitioners in producing contaminant-free organic products. There are direct as well as indirect modes of contamination. The contaminants are come to soil surface through runoff, drainage, infiltration, groundwater flow and exploitation of contaminated groundwater. Contamination control is the process of containing the spread of the contaminants in the environment, especially in soil, watercourses, reservoirs, and wells in order to produce organic farm produce that can meet the standards of certifying agencies. The certification agencies analyze the soil, water and products for content of any form of contaminants. If the limit of any contaminant is found beyond the prescribed standards, the certificate of being organic to the product is not awarded. The agencies also suggest remedial measure to reduce or prevent further contamination to the organic farm. Thank you.